All right, so I just wanted to do a couple examples of kinematics problems from the problem set. I'll do one that is a little bit more visual, and then another one that is a little more just from the equation conceptual. So here's a graph, and I'm not going to reproduce it perfectly, but here's a graph that represents you walking eastward. You begin walking eastward. So the graph goes up, down, straight line, curve, and the maxima and minima are labeled and the zeros are labeled. So this is the image that we have to go off of. I guess that one is not labeled, but it'll be 6 comma 0, and then this is 9 comma 2, and this is 11 comma 0. And we're supposed to just analyze what this is. Basically, all the times we're standing still, all the times we're moving in either direction, when are you moving quickest, all of those sorts of things. So what I notice is that um, this is actually my velocity. So that's really crucial here. This is not my position. If this was my position, then it's telling me the t is like the x value, and then the y value would just be where I am, east or west. But this is actually my velocity. So each of these y values is measured in meters per second. I guess it doesn't specify that. So it could be miles per hour, it could be feet per minute. I'm just going to write meters per second just to try to help conceptualize what's happening here. But all it really is distance per time. Um, just meters per second is pretty common. So what do I know here? That whenever the meters per second is positive, I'm moving in the positive direction. And the question says that we are going east. So for all of these intervals, so from 0 to 3 and from 6 to 11, we are moving east. And from 3 to 6, we are moving west. Because from 3 to 6 is when the graph is negative, and a negative direction just means the opposite of the positive direction. Standing still happens at these zeros right here. So there's 4 spots where we are standing still. We're standing still at 0, 0, 3, 0, 6, 0, and 11, 0. So those are standing still. Now, those are telling you the times that you're standing still. It's not saying you're at the same position. It's just saying that at those points, your velocity is 0. So you're standing still. What about the times when you're moving the most quickly? Well, that would be the maxima or the minima. So you're moving the quickest up here. This is the highest point of all. So after 1.5 seconds, you're moving the quickest eastward. After 4.5 seconds, you're moving the quickest westward at the same speed. Both of those have the same speed of 3, but one is 3 moving east, the other one is 3 moving west. And then the times that you are speeding up or slowing down, that is when your velocity has a positive slope or a negative slope. And you just have to be a little careful because we're talking about speed here as opposed to velocity. So for example, right here, we are speeding up. Here, we are slowing. From here to here, we're slowing down. Here, we are stopped. Here, we are speeding up again. Even though this is a negative derivative, we're speeding up in the negative direction. Here, we are slowing. Here, stop, speeding, slowing, and stopped. So that's a nice problem for just really understanding the graph. When I first looked at the graph, I almost started making this video as if that was a position graph, but then I double checked the y-axis was labeled with a V, So then I reread the question. I saw the word velocity. It's not actually a position graph. So everything I just said would have been completely different if it had been a position graph that I was looking at instead of a velocity graph. Okay. I want to do one other one where they just give you an equation and ask you to figure out things about the velocity and the acceleration. So here we just have s of t equals negative t cubed minus 3t squared plus 4t plus 3. So s prime of t, negative 3t squared minus 6t plus 4. S double prime of t is negative 6t minus 6. So we want to describe the motion of the particle here. So one thing I notice is that this right here is negative, negative when t is greater than 0. It's actually negative a little bit more than that, but usually we just kind of think of t equals 0 as the beginning of the situation. So if I'm thinking of at a time t here, the second derivative is negative. And what that means is that the acceleration is negative. Well, in other words, the particle is slowing down. Okay. Then when I look here at this first derivative, it's positive when t equals 0, and then when t is equal to 1, it's negative. And so I know that the particle it's positive when t equals 0, and it's negative when t equals 1. Of course, I could figure out when it's exactly 0 by using the quadratic formula or something. And that might be useful information. I don't really need it at this moment. All I know is that it was positive, so it has a positive velocity. It's moving forward, and then it has a negative velocity. It's moving backwards. And so here I know that the particle is slowing down along that whole time. That it starts out moving forward and then it ends moving backwards. And same idea here, that this begins positive and then eventually it becomes negative. So the particle starts out in front, 3 meters in front, I guess centimeters, 3 centimeters in front of the starting line because of the 3 right here, at a speed of 4 centimeters per second. It slows down and eventually moves backwards. So slowing down and turning around, I should say, then speeding up, like we saw with the graph I was just drawing, that when you go down below the x-axis on your velocity, it kind of speeds back up, and that it is always moving faster and faster into the negative direction. All right, there you go. Please ask questions about kinematics if there are any other problems you want or any other wonderings you have, and I will help out. Thanks.